These cells tend to form tumors like teratomas. Rather than to make nice new heart muscles or kidney cells or whatever you hope to get, they form tumors. We also build immune response against these cells. They're also hugely expensive to get these cells specific for a recipient's body. You have to put the mother at risk to get the egg cells to produce this. So this is not an area likely to lead to substantial clinical success. And yet that's all you hear. Embryonic stem cell, oh, we have to have the embryos. All of the successes, I did not say most, I said all of the successes have come from adult stem cells that do not involve killing embryos. And yet people come up all the time and say, do you favor stem cell research? Sorry, wrong question. Are you asking me, do I favor embryonic stem cell research or adult stem cell research? But no, it's always stem cell research. They want to blend this in. You may be wondering, if this makes everything in the baby's body, what are these cells doing out here? There's something you're forgetting. You've got mother. That's one kind of tissue, right? The mother's body. You've got the baby that has its own tissue, its own body, its own immune system, what have you. What's the third thing? The placenta. The placenta is not the mother. The placenta is not the baby. It's neither. It's an organ that sits between mother and baby as an interface, and this organ is quite simply the most incredible organ in the body. In fact, when I taught at the medical school, I didn't even call it the placenta. I just called it super organ. And my students knew what I was talking about when I said that. You see, these cells are going to make the placenta. Imagine we have this projector here. It's very, very nice, and now we say, let's turn it on, but it's not working. Oh, we forgot to plug it in. So we take the plug, we go over to the wall. There's 3 little holes. Can it be that big a deal, 3 holes in the wall? But attached to those 3 holes is an entire electric company. It's more complicated than the projector. This is what we have with the placenta. This placenta needs to get started in advance of the baby. It's the plug-in. You see, placental mammals are like plug-in devices, whereas amniotes, like reptiles and birds, are like battery-operated devices. They get their energy from stored yolk in the egg. We get ours from plugging in. This is just an amazing story here. This is how big the blastocyst is. Some people say, how can you say this is a human being? It's so tiny. God would never pay any attention to anything this small. Wait a minute, the Bible says, what is man that thou art mindful of us? Compared to the universe, we're not very big. God knows and loves us. Jesus was a blastocyst at one stage of his development when he was forming in the womb. Well, let's get down to the actual implantation. At 5.5 to 6 days, this blastocyst burrows right into the uterine wall. Now that's amazing. The mother should never allow this baby in. The baby is a whole different human being, just as different as each of you are from your mother. And the immune system is working in the mother. The graft rejection system is working, but this baby does not get rejected. And if it did, it'd be the end of life. That has to be one big, huge whoosh, if you're an evolutionist. This shows the blastocyst penetrating the uterine wall. Now, this is incredible right here. The blue colored, just for purposes of illustration, is the baby. That's the embryoblast, or the thing they kill, or the part they kill to form embryonic stem cells. What's shown in red, those are called cytotrophoblast cells, and these cells start fusing together. Think of a cell here, and they fuse. They make one cell with 2 nuclei. Another cell fuses. You now have one cell with 3 nuclei, and then 4 and 5 and 6. You end up with a large cell with millions and millions of nuclei that forms the entire surface of the placenta. It is the largest single cell in the body. How big is it? About like an 8-foot by 10-foot area rug if you were to flatten it all out. And one cell. Mother's blood is on one side of this cell, baby's blood is on the other, and everything has to go through that seamless barrier. Now let me interject something. I was actually an editor for Stedman's Medical Dictionary for 5 editions, and I was working as the histology editor when the 26th edition was published in 1995. This is a standard medical dictionary. And we defined conception in 1995. I didn't have this particular term to define. It went to the people in into obstetrics and gynecology. But conception was defined as the act of conceiving or becoming pregnant, fertilization of the oocyte by a spermatozoa to form a viable zygote. That's conception. Today, an English dictionary like the Oxford Unabridged, the definitive dictionary of the English language, defines conception in the same way. But between the 26th edition and the 27th edition of Stedman's that came out in 2000, a new technology began in 1998 of basically producing human clones called somatic cell nuclear transfer to make these blastocysts and to use them for body parts. And so what the dictionary did was to change the definition of conception so you could say you weren't killing a baby or you weren't making a clone. Look what they did to the definition. See this one? They took that part out and they put this part in. The implantation of the blastocyst into the endometrium. They moved it from fertilization all the way to implanting in the uterine wall. That gave them 9 to 10 days to play with after fertilization, where you could insist it's not a human yet and kill it or use it to clone or whatever. And that is the definition recognized in the packaging that comes with the morning after pill that assures you it will have no effect after conception. This is the way the baby looks as the placenta begins to develop in earnest. It develops all the way around the baby like a sphere. Here's the developing baby here. The black is the tissue of the placenta. The white is where mother's blood can flow in, because as this syncytial trophoblast invaded into the uterus, it actually eroded the ends off the arteries and veins in the uterine wall.